All right, hello everyone, and thank you for joining us for today's virtual summit. My name is Hannah Zwick, and I'm the Director of Marketing at CourseKey. For those of you unfamiliar with us, we're a mobile attendance tracking platform used on more than 80 campuses across the country. We're very excited to be facilitating today's events, and we hope that you can attend as many as your schedule allows for. This is the first of 7, so we have a full day of content planned for you. For the next hour, we'll be hearing from Dr. Jamie Jensen on the topic Teaching to the Test or Testing to Teach. Dr. Jensen is an associate professor at Brigham Young University, and she conducts research in the learning environment through her introductory biology courses. Again, we're seeking to have a lively Q&A discussion at the end, so please feel free to ask questions throughout the presentation. And finally, we'll end this presentation at about 8:55 a.m. Pacific to honor our commitment to bring you this content in under an hour. So without further ado, it's my pleasure to pass the mic over to Dr. Jensen.
Oh, shoot.
Oh, we've got you.
Do you have me? Because I can hardly hear you.
Oh, I'm sorry. That's odd. No, we have you. You sound crystal clear.
Okay. Okay, so I will go ahead and get started then. All right, so I'm going to talk about testing, and stop me if I ever get a little weird audio and I will walk inside. I am stuck in a car outside of a gym in a small town in Utah, so we'll see how the internet holds. Okay, so as we're designing classes, we are all probably familiar with backwards design. So this is looking at learning outcomes. What do we really want the students to be able to do by the time we're done with the class? And from those learning outcomes, we design assessments to determine what acceptable evidence would tell us that we've met our learning outcomes. And then from there, we should plan our learning experiences for the students in the classroom. And sometimes those assessments sort of take a back seat to all the rest of the things that we're doing. And maybe that's my question, is that important? So one of the things we want to ask is, can we use Bloom's taxonomy to inform the way that we write our test questions? So again, I'm sure you're probably familiar with Bloom's taxonomy, but this is a taxonomy of learning objectives that kind of defines what you want students to know. So the first 2 levels down at the bottom are what we call, in this study, we're calling them low-level cognitive skills. So this is just being able to recall the content that you've learned and spit it back at the teacher. The higher levels, from apply up to create, require more cognitive skill, not just knowing the content, but being able to use the content in some meaningful way. And in this study, we're going to refer to those as high level. So interestingly, in 2010, Jenny Momsen did a study where she looked at 50 different faculty across several universities teaching a bunch of introductory courses. And she looked at what they had listed as their learning outcomes in their syllabus, and then what they were actually testing in their actual exams. And what they found is that our intentions, our learning outcomes, are often much higher than what we actually assess on. And if you talk to any introductory biology student, what they're expecting from the test is just memorization. And so this isn't surprising, because this is mostly what we do. And so our question was, if our learning objectives are actually focused on higher level cognitive skills, we do want students to be able to do these higher order things, does it matter how we design our assessments? And then if you've got this limited instructional time with students, can you use your exams to promote these higher levels of learning? And then we're going to use this testing effect, because the testing effect can help students. So let's talk about this testing effect and what it actually is. So if we're talking about the testing effect, so you might learn some particular materials, and you have students restudy those materials, and then at the end they take some kind of criterion exam, like the final exam. Versus if you have them learn the material and then you test them on it, or they test themselves using flashcards or whatever, and then take the criterion exam. Researchers have studied this in lots of different environments and found that restudy is not nearly as effective as testing. Even though they're talking about the same content, being able to actively recall that from memory seems to strengthen the connections to the material and make it easier to recall in the future. But a lot of the testing effect research has been done on low-level cognitive skills, like memorizing vocabulary words and that kind of thing. And so we wanted to know if this is equally effective in a high-level situation, which is what we want in a biology class. So to test this, we set up this experiment. We had 2 sections of an introductory biology course. They were taught by the same instructor, me, and they were taught inquiry style, so we used the 5E learning cycle. We used the same text, we were in the same classroom, the classes were back to back, they did the same assignments, the teaching assistants were the same. So we tried to keep everything as the same as possible. But in one section, their unit exams were all low-level Bloom's taxonomy. So they were just remember and understand. In the high-level section, all of their exams were 100% high-level. There was no recall of information. It was all complex problem solving throughout the course. And so they all were taught the same way, but their exams looked very different. And then at the end of the semester, they both took the same final exam. So we wanted to know if the tests influenced their learning. So I'm going to give you some sample exam questions just so you can see the type of thing that I'm talking about. What is the difference between a low level and a high level question? Right, so here's some high level questions, and I'm actually going to give you just a second to think about them, and you can go ahead and vote. So if Hannah, you could start that first poll, that would be great.
All right, the poll is live now.
Okay, so we'll give you just a second to answer those questions. How are we doing, Hannah? Are people answering?
Yeah, we're getting a couple in.
Okay. And we'll just give it a few more seconds.
All right, we're almost up to the 1 minute mark, so let's cut it off there.
Okay, sounds good. All right, so hopefully you got the right answers. Can I continue with that?
Yep, it is all yours now.
All right, so here's our answers. So hopefully you got the right answer, but you can see from these problems that not only do you need to know the content, for instance, in number 1, how many chromosomes are in a haploid cell, but you need to be able to apply it to this particular problem. For number 2, there is some content there about trisomy, but you need to be able to apply it in this practical situation. So those would be the high-level questions. Now I'll show you the low-level questions that directly correspond to these. Right, so the first one, in humans, the haploid number equals what? And trisomy is what, right? And so we tried to match them up, the high level and low level questions between classes. Okay, so lest you think that maybe, you know, section were just way too easy, so they weren't getting their preparation, these are the unit exam averages on low level and high level. So we made them quite extensive and rather long. And so we ended up with pretty equal scores. And statistically, they are equal scores between sections on the actual unit exam. So they were challenging. But interestingly, I'll just add this tidbit. The low-level exams took on average students about 50 minutes to take, whereas the high-level exams, I think our average testing time was about 3 hours. So they were 100 questions long. I would never do this to students again, but they spent a long time taking these exams. All right, so the dependent measures that we looked at, so we used Lawson's classroom test of scientific reasoning. If you're not familiar with this test, it's a content-independent test of Piaget's formal operational reasoning skills. So like identifying controlling variables, probabilistic reasoning, proportions, things like that. And it seems to be a really good predictor of performance in introductory STEM courses. So we usually measure that as a covariate for group equivalence instead of using something like GPA. So we used that, and then we looked at achievement on the final exam. So the final exam was half low-level Bloom's items and half high-level Bloom's items. And again, both sections took the same final. And then we also looked at student course evaluations. So let's go through some theoretical factors and predictions. And I'm actually going to have you predict, but we'll do this quickly. So direct testing effects. It could be that high-level questions, and I'll put up the votes here, that high-level questions on unit exams facilitate direct performance on the high-level final exam items. So if this were the case, that just taking high-level exams during the semester is going to help you on high-level exams on the final, looking at our 3 predictions, so I'm going to help orient you to these. And Hannah, if you could start the poll, that'd be great.
Perfect, poll is started.
So the low-level final, let's see if I can move that out of the way. I don't know if it's on the same for you guys. So the low level and the high level, the left and right set of graphs, That's the exam items on the final. So the low-level final exams, the high-level final exams, and then along the x-axis is the treatment, whether they were in the low-level treatment where they took all low-level exams, or whether they're in the high-level treatment where they took all high-level exams. So if it is just the case that high-level questioning helps you with that particular skill, what would you expect to see on the final exam? Okay, we'll give it maybe 10 more seconds for votes.
Sounds good.
Okay, and then Hannah, if you can tell me what the predominant vote is, that would be great.
Sure. So I'm going to stop it right now. And we have had 63% of the audience has responded A.
As A, okay. So, whoops, am I moving here? Oh, I need to go back on here. Okay, so that's interesting. Yeah, so we're expecting if it just helps you on a high-level skill that you would only see high-level performance increase for those in the high-level group. But if you're looking at high-level questions on unit exams, they would encourage significant elaborative practices, so that would facilitate both high-level and low-level performance. Then you might see what you guys were guessing, where the high-level treatment would do better on both. And so we'll skip the poll on this one. This is the prediction that most people are making for the first one. But the first one, we're saying that only the high-level, whatever that practice is helping you. Whereas the second one is saying if you're performing on these high-level exams, somehow it's sort of trickling down to low-level performance. And so the high-level treatment would do better in both conditions. I hope that makes sense. But there is a third alternative, and it's called transfer appropriate processing. And this is where whatever you're doing on the unit exams, that process that you're doing, either memorizing or high-level problem solving, should translate into that same performance on the final exam. So in this case, well, let's go ahead and do a poll and make sure we understand this. What would you expect for the transfer appropriate processing? So we'll give you like 30 seconds. And Hannah, you'll have to tell me when 30 seconds is up.
I will. We're at 20 right now.
Okay.
All right, so we hit 30 seconds, and this time we've had 56% of the audience respond C.
Perfect. Okay, yeah, so we would expect whatever process you're doing in the unit exam should transfer over to that process in the final exam. Now, interestingly, so this would be our 3 predictions, and you can see that they're different, so it's a good way to tell these apart. But what we can't take into account is there's also indirect testing effects. So again, Hannah, if you'll start the poll while I explain this. So indirect testing effects is where it's not the test itself that's helping you, but it's in your preparation for the test that you're receiving the benefits. So the first hypothesis we had is that students are adjusting their study habits to either practice just memorizing or to practice doing high-level tests or high-level problem solving. And so in that case, what would you expect in your 2 different treatments on the final exam? So we'll give you just about 30 seconds to answer that.
All right, so we made the 30-second mark, and we have a tie between B and C with 43% each.
Okay, so let's think this through. If the students are just practicing memorizing during their unit exams because they're taking low level, then you would expect them to be really good at memorizing, right? And if they're just doing high level during this semester, you would expect them to be really good at high level because that's what they've been focusing on. So the answer is C for that particular one. And then there is one other option for indirect testing effects. I'll put the poll up again. If you're studying for high-level unit exams and that necessitates you to learn the low-level content, in other words, Bloom's taxonomy is hierarchical. So in order to do the high-level stuff, you have to automatically learn the low-level content. Then what would we expect on the final exam? So we'll give you 30 seconds again.
All right, and so this time we've had 57% of respondents say A.
Excellent. Yeah, so we would expect them to do well on both because they're learning the content in order to solve the complex problems. Okay, so those are theoretical rationales for indirect testing. So let's actually take a look at what we see. So here's our results. On the low-level final exams, you can see that the high-level condition did significantly better. And on the high-level final exam items, again, the high-level condition did significantly better. So it turns out that using high-level tests on the unit exams facilitates not just their high-level problem solving, but also just their knowledge of the content, which was a little surprising to us that it transferred over like that. We did use the pre-LCTSR as a covariate. Like I said, again, it's a good predictor of performance. But we also took a minute to take a look. Oh, let me tell you, so this is what it supports. So either it's a direct effective testing that high-level questions on the unit exam, like while you're taking the exam, promote these elaborative practices that strengthen your connections to the low-level content, or it's an indirect effect, because these both lead to the same prediction, that studying for these high-level exams causes you to learn the content beforehand, and it's not the test itself necessarily, it's just what the test prompted you to do at home. Either way, we're thinking that it may be that this high-level testing effect trickles down to the low-level items, or at least in our studying. We also did take a look at scientific reasoning gains over the course of the semester. We see a modest gain of about 1.5 to 2 points on a 24-point scale. That's how big the test is, 24 points. But we see a significant gain in both treatments. So from that, we took that it's probably not the exams themselves that are prompting reasoning gains. It's more likely a result of inquiry instruction, and reasoning gains are pretty modest. But we are working with students who are really high achieving students who are at a selective university, and they're kind of hitting the ceiling of the test. So, all right, so student comments though, I wanted to point this out. So in the low-level treatment, most of the comments are probably typical of the things you would expect to hear from students complaining about exams, like the professor's trying to trick me, or there's just a lot of questions and we didn't talk about them long enough in class and that kind of thing. Whereas if you look at the high-level treatment comments, they are recognizing that this is testing them on more than just recalling content. So for instance, that second comment, I didn't feel like the tests were a good measure of our learning. I felt a lot of it was basic science reasoning. Yay, I was really excited to see that. Kind of like the science on the ACT exam. The exams were long and time consuming, and I know me and the other students thought they tested your test taking ability rather than the material taught in class. But if you look at the second to last one, tests were extremely well written and actually provided opportunities to learn and acquire application skills, a rare feat in a test situation. So we were kind of split half and half between students who resented me and students who saw it and appreciated it for what it was, that we were testing them on actual skills that might be transferable to other situations. So, general conclusions. Exams requiring higher order cognitive skills do lead to greater learning gains. We don't know whether it's direct or indirect, but students hate them and they were way too long. Like they were spending way too much time in the testing center taking these exams. And it suggests that maybe Bloom's taxonomy is hierarchical. In other words, to be able to perform these higher levels of Bloom's, they have to master the lower levels. But that we're still actually testing. And so what is the application though from this? And I would say the application is throw out the fluff. I know we feel very tempted to put in these low-level questions and just do low-level because that's what the students are expecting. But if you really want them to master these high-level learning outcomes, it's important that you put them on the test. And you don't have to put that low-level stuff on there. They're going to get it anyway. But I will tell you anecdotally, and we've actually done another study that we're working on analyzing the results, where we put in like half fluff, we call it fluff, the low-level questions. And what it did is it gave students like little boosts of confidence during the test because they could answer these low-level questions. And so I don't think it's necessarily a bad thing to sprinkle in the content, but it's not so that I can make sure they have the content. It's more just to help students have a more pleasant test-taking experience. All right, so once we saw this high-level testing effect, we really were interested in what's actually going on. So are we strengthening just access to the content? Like most of the testing effect research has shown that it's strengthening those connections to the content? Or Are we strengthening their ability to use these skills, like analyzing data and drawing conclusions and identifying variables? Or is it a combination of both? Maybe we're only strengthening those skills on particular content and not necessarily universally. And so that's what we set out to test in this second study. So it's kind of a crazy experimental setup, so let me kind of orient you to this. And so what we did is we taught another introductory biology course, and we did all of the unit exams high level, but we shortened them down a little bit so they weren't quite so intense. Oh, actually, no, we did not. Oh my goodness, we tortured students. No, they were still 100 questions because we were comparing them back to that other study. Anyway, so they took these high-level exams throughout the semester. And then the final exam, we divided it up into high-level and low-level, but we also divided it up into tested and untested. Okay, so let me explain how that works. So we looked at our learning outcomes. So this is just an example of 4 days of my learning outcomes for the class. So we looked at the learning outcomes and we divided them up into tested content and untested content. So all of the learning outcomes are being covered during class and homework assignments, and so we're covering all of them. But when it comes to the unit exam, you can't possibly put all of them on the unit exam. So some of them appeared on the unit exam, and we called them tested, and some of the content did not appear on the unit exam, but was covered in class. So for instance, if you're looking at day 17, this is on Hardy-Weinberg, mechanisms of evolution. So there's genetic drift, mutation, gene flow, natural selection, non-random mating. But only genetic drift, gene flow, and non-random mating appeared on the test, and that would be considered our tested. But then the untested would be those that didn't appear. So mutation and natural selection. So the same types of questions, but on content that didn't appear on a unit exam. All right, so here are some examples, and I'm going to let you pull on this one, see if you can answer these. So this is a high level. On the left is the high level tested item from the final exam, and on the right is what had appeared on the unit exam. So the content being tested should be the same, which is X linkage on both of those. So just take a minute, see if you can answer these just for fun.
All right, and we've got about 15 seconds left in that 1 minute.
Perfect.
All right, for that first question, we have 100% have answered B, and for the second, 75% have answered B.
All right, so let's see how we did. Okay, so one of the things we're just messing up on is if it's a male, and this is sort of a tricky question. But anyway, so that's the high level. Here's the low level, and we'll just actually skip the poll on these because they're pretty easy, but you can see the low level tested item is on photosynthesis, okay? And the unit exam item is on the same concept in photosynthesis, that molecular oxygen is released from photosystem 2, okay? So this is how they were matched up with low level tested and the unit exam item. Okay, so that's how we did those. And the untested would be the similar type of question, but using content that was not tested in a unit exam. Okay, so let's look at, we are going to make some predictions here. Sorry, I kind of skipped over that other question. Oh, well, anyway, we're going to move on. So looking at the unit exam items, if there is a testing effect, so that was the first thing we wanted to establish. We wanted to reestablish in this second experiment that there really is a testing effect, that we really do better on tested items than untested items. And so we looked at unit exam items, and then we looked at those tested versus those untested items. And if there is a testing effect, we would expect to see that they do better on the tested items than the untested items, whether it's because of the content that they know better or the skills that they know better. Either one would lead to the same conclusion. But we also wanted to know if there's this possible transfer of the testing effect to the low-level content. Are they going to know the content better? And if that's the case, then we should again expect low-level tested items to be better than low-level untested items. And we were surprised to see that not exactly. So we did see this testing effect for high-level items. So they did much better on tested high-level items than untested high-level items. And remember, these are not the same items, right? They're just tested content, but using some other scenario, some different thing. But they did better on content that was tested than untested, but it did not seem to trickle over, or it trickled over equally, this is hard to tell, to the low level. So there was no difference between tested and untested in the low level. So they either did equally well or equally poorly, depending on how you want to look at it. So that was interesting to us, that maybe it's not trickling over into low-level content, or in their preparations for high-level exams, they get all the content. And so we don't know. So in order to solve that, we decided to give them a testing situation on the final exam where all content was available. So it was open book. So we have one section on the top that's taking a closed book final, just like that last study. So this is a new set of students. In the bottom, they're taking the content untested, or I'm sorry, they're taking the final exam open book. So they're not being tested on content. The content can be looked up. Okay, I hope that makes sense. And so if it's a testing effect on content, in other words, if we're seeing this high-level testing effect because testing them at a high level increases their access to the content, so they're better at the content, then what would you expect? So we're going to go ahead and do a poll here. What would you expect to happen in an open book treatment where content is readily available? So if it's just because of content, better content connections, giving them the content readily available, what should happen? So we'll give you like 30 seconds, A or B. So either the testing effect remains or the testing effect disappears when it's open book.
All right, a couple more seconds for you guys. All right, so we have had 60% answer B.
Very nice. Okay, yeah, so we should expect to see that if the content is totally available, then that testing effect of knowing the content better should sort of disappear, and the testing effect would be mitigated in an open book example. Now, let's look at the alternative. Let's say that the testing effect is not that it strengthens our access to the content, but rather it strengthens the students' access to the skills. They're better able to use the skills. So in that case, again, let's predict, if we'll start a poll, if it's a skill issue, then what would we expect? If you give them all the content, is that going to help them and mitigate the testing effect, or will the testing effect remain? So we should only need like 20 seconds here since we've already answered this one.
All right, about 5 more seconds. All right, at 21 seconds, we have an even 50-50 split.
Ooh, interesting. Yeah, so our rationale here, and maybe we could be interpreting this differently, but our rationale here was that if it is solely skills, so not necessarily, and you may think, well, it's really probably not solely skills, and I would agree it's not solely skills, but if it was solely the skill necessary, then giving them content shouldn't influence whether or not they can use the skill. So we predicted that you would see the testing effect regardless. If they've got the skill, they've got it. If they don't, they don't, and giving them content shouldn't matter. So this was our predictions for it. Excuse me. This is what we saw. So this is sort of a complicated graph. We're going to go through it one thing at a time. So you can see that the gray is in the closed book situation. The purple is in the open book situation. And then along the x-axis is the 4 different final exam item types. And so what we see is that the open book treatment shows equal improvement on both types of low-level items. So having content available made them better able to perform on low-level items, whether they were tested or not. Now, notice though where our bars are. They're around 70%. So this is a little baffling to us because these are, very competitive, high-performing students who just didn't bother to look things up and only got 70-ish% of them correct, even with total access to open book and open note. So that was a little puzzling, but they did do better by having content available. Looking at high level, they actually did a little bit better on high level items, but it didn't reach statistical significance. So that sort of hints at the idea that performance on the high level items is indeed content dependent a bit, and that having the content available does increase that ability. However, our testing effect remained in both conditions. So regardless of having the content, we're still seeing this testing effect. And so what we're looking at, first of all, tested and untested refers only to the content, like genetic drift versus gene flow, or natural selection versus mutation. The skills that were used in tested and untested questions were not unique. We're analyzing data, drawing conclusions, hypothetical deductive reasoning, evaluating arguments. So it's interesting that, if they've got the skill and they get the skill better when they're tested on it in a previous situation, why can't they transfer that to untested content since the skill is the same? And you might be thinking, well, gosh, transfer, this is a big issue in education. And it is. And it turns out that these skills are not easily transferable from one situation to another, which is kind of a bummer because we would hope that if we could teach them the skill, they could use it everywhere. But it turns out they can't. So we've come up with a model that we believe kind of captures what's going on here. That in order to perform on a high-level target application question, that it requires three things. It requires the content knowledge. And we saw this, giving them content does make it better. It requires the cognitive skill. But if you have just the content knowledge or just the cognitive skill, you're likely to miss the mark. And so it's that practice of connecting a particular cognitive skill to a particular piece of content that allows you to hit that target. Now, for me, that was a little bit discouraging because I thought, how in the world? That means we have to test them in every situation with every skill on every content. I mean, and the short answer is yes, but maybe there's a way around that, and we'll talk about that in a second. But we did want to test our model. Now, this data is just sort of preliminary. We did it on a small, we had a small number of questions that we did this with, but it was interesting. We wanted to see if this model was actually correct. So we picked 8 high-level questions from the final exam, and we tried to identify what is the content that they need to know, and then what is the skill that they need to be able to do. So we could tease those apart. And so, for instance, we have this high-level question. It says the human hexokinase enzyme has the same function as the bacterial hexokinase enzyme, but it's somewhat different amino acid sequence. You've obtained a mutant bacterial strain in which the gene for hexokinase and its promoter are missing. If you introduce into your mutant strain a DNA plasmid engineered to contain the coding sequence of a human hexokinase gene, driven by the normal bacterial promoter, what will the bacteria produce? So they'll either produce the bacterial form, the human form, some kind of hybrid, or both. So we looked at that question and we said, okay, what is the actual content that they need to understand in order to answer that question? So we came up with this content question. If you place a human gene into a bacteria, when the bacteria reads the gene, what does it produce? A human protein, a bacteria protein. So this was the content that they needed to know to answer that question. And then we tried to figure out what's the skill. They're making a prediction based on some kind of experimental setup. So we gave them a really easy one that wouldn't require any background knowledge. So these burying beetles lay babies on dead carcasses, gross. The mother beetle measures the size of the carcass only once before laying her eggs, and she lays the number of eggs based on the amount of food available. So if we switch out her carcass after she lays her eggs with a smaller carcass, what's going to happen? So there's no background knowledge required. They just need to be able to say, if in this situation and this is going on, then this should happen. So that's kind of how we did it. So, and it's, this was really difficult to do and to say for sure that these are the skills, but it seemed pretty reasonable. So our idea was we could look at their performance on the content items, their performance on the skill items, and then how well they did on the tested or the untested high-level items. What we found is that all of our skill questions were just way too easy. Like they could get all of them because they can reason. Like I said, they're really high achieving students and they're hitting the top of that reasoning test. So they didn't have any problem with any of our skills. So we just had to ignore the skills. So then we looked at the content items and we thought, okay, if it's that you can only apply the skill to content you've applied the skill to before, then having the content would have a stronger correlation with high-level tested items. In other words, if you know the content, then you can apply the skill, than with untested items. So even though you know the content, you're not able to apply the skill. And so we would see a stronger correlation with tested items than untested items when you know the content. And so we just did a simple correlation analysis, and lo and behold, you do have a stronger correlation with content in high-level tested than content in untested, and it's statistically significantly different. So like I said, though, these are size, and I feel like our questions need to be vetted more. But it was kind of an interesting test of our model. So our model, again, is that you need both the content and the skill, and that you need to have practice with those connections. So really the question becomes, the practice with those connections, does it have to be in a testing situation? Right? Because if it really is that you have to test them on every skill, on every content, in order for them to make that connection, how do we do that in a classroom? Because we can't possibly give them that many test questions. And so we've been messing with all kinds of different iterations of this. Can we do it on a homework assignment? Like, how does it need to have high stakes? Does it need to have high points available? That's the stakes. Or does it need to be in a testing situation where they're feeling that anxiety? So we've been looking at all different things, trying to figure out how can we get that same effect where we get those connections without having to just test students with thousands and thousands of questions on exams. And so with that, that's what we've done. And we've done a bunch of other things that we're trying to work on with the testing effect. But I'd like to thank all these people for their help in this project. And I guess I will take questions. How'd we do? Great.
Awesome. Well, first off, thank you, Dr. Jensen, for that wonderful presentation. For those of you in the audience, if you haven't submitted questions yet, please do so now. We have about 15 minutes left of time bucketed together, so we do have some time for Q&A. Dr. Jensen, in the meantime, the first question we've had is, taking it out of a lecture environment, how do you think the results of these tests might differ in a lab or a clinical teaching setting?
Very good. Yeah, so we've actually done some work not on the testing effect, but in a clinical environment at a dental school. And I think that these would apply exactly the same way, such that, you know, and it's a little discouraging, I hate to say it, but that if they don't try a particular skill, like a hand skill, let's say, in at least many different situations. And that's the other thing that we haven't actually established, is how many different, maybe if you use it in 5 different situations, that's enough to make it transferable to any situation, or does it have to be that you do it 10 times? And that's the bounds that we're still trying to figure out. But I would say the same thing for a clinical setting or a laboratory setting, that you've got to use the skill in more than one situation in a tested environment, in an environment where you're pulling things actively from memory, in order to have those skills be transferable across contexts.
Wonderful. And then the next question is one that was actually submitted before the presentation started. How do you teach or establish best practices for a student to be successful on a required certification test while making sure they still have the hands-on knowledge for their profession in a compressed amount of time?
That's like the oldest question in the book. How do we fit it all in, right, in a compressed amount of time? So one of the things that I have utilized in my classrooms, at least, is that I put a lot on the students outside of class, right? So inside of class is where I reserve the application, and actually that's where a flipped classroom actually becomes a really great tool, in that you're doing the application in class where they can be scaffolded by instructors and peers. But there's a lot you can have students do outside of class as far as getting the basic content and doing practice. So we've done it both ways at BYU, flipped and non-flipped. Either way, we give them lots of practice applying. But yeah, fitting it in is always the challenge, right?
Yeah, and next we've had, based on your research, would you recommend that every program have an internship or externship to assess skills in order for a student to successfully demonstrate competencies of a subject?
That's a great question. That would be ideal, right? I think that the skills themselves are the most important, because the knowledge, especially today, when all information can kind of be looked up, it's those skills that are most important, and it's the application of those skills, right, that is the most important. And interestingly, I'll just bring this up because it's something we've been working on. We noticed that LCTSR test that I was talking about, those are totally 100% skills. They're not content-based, and they're highly predictive of a student's performance in STEM classes. And so we've actually been developing an application, like an app on your phone, that students can go in and explicitly practice those skills beforehand so that they can be prepared. So not just an internship at the end of your program, but I would recommend that students coming into the program should be assessed for the skills that they have and don't have, and should be explicitly taught skills like right from the beginning so that they can be successful. And we've run a little bit of this analysis, and we've given this particular app to Bio 100 students, and we found that we can improve those skills in a matter of about 2 weeks, and it improves their grades in the class by about half a letter grade by giving them the skills ahead of time. So, but yeah, an internship is a great idea.
Awesome. That's great feedback. And the next is, how do you recommend instructors and faculty and program directors work together to design experiments like this and to make sure they're being delivered in a consistent manner?
The experiments being delivered in a consistent manner?
I think it's more along the lines of like test questions and making sure students have those opportunities.
Okay, so maybe I'm going to answer it 2 ways because I'm not exactly sure I understand the question. But if we're talking about experiments like this, working together, I think it's really important that we establish, and I teach this to students because this is the kind of research that I do, but it's really important to establish, and we use backwards design just the same way that we would use backwards design in the classroom. And that is, what is your research outcome? What do you really want to accomplish for students? So in my case, it was that I wanted students to be able to use high-level skills in a practical situation. And so from that, we design experiments, but we make sure that our hypotheses are based in a theoretical rationale, a learning theory. So I think it's really important when teachers are trying to assess what's best in the classroom that you involve somebody who's a pedagogical or research expert who might have access to those theories. So when we're talking about the testing effect, this is a really complex theory that's been tested lots of times and can be brought into the classroom. So having a DBER, a discipline-based education researcher, that collaborates with you to design these experiments is ideal, and then testing them in the classroom. Now, if it's the other way, this question can be interpreted, that we want to make sure that testing is even. I think that getting data like this out there to show that this really is a good practice is a big motivator for professors to change their practices. And so I am not a big fan of administration coming down and saying, we're going to make this change, everybody needs to do it, let's all get on board, without some kind of research data to say that this is a good idea. And so at BYU, like, we just did a program, they did BYU Online, and they want all students now to take at least 14 credit hours of their undergraduate online. But they did it without doing any testing first to see if this was a good idea. And so they recruited me to do a bunch of tests. We've been doing like 3.5 years of tests on like, what does an online class have to actually be? And does this benefit students or does it hurt students? And gathering that data before we make a huge institutional change and requirement for people to be all on the same page. I don't know if that answered the question, but those are my rambling thoughts.
Cool. Well, maybe we'll get some feedback from the asker and see if they have
Sure.
any clarifying points. So those were all the questions we had right now. Let's give it another minute to see if anybody wants to toss in any more. We do still have a little time together, but otherwise we can let everyone go early. But for those of you still in the audience, we've still got some time. So if you have questions, submit those right now.
Yeah, sounds good.
I'll give it to about the 30 or 40 more seconds and see if we get anything else. We had the question, will the PowerPoint presentation be available to the attendees later? We're actually recording all of the sessions, and attendees will get a copy of the recording after. And another question came in. One question was, it seems your presumed students would do better on an open book test. Is that always the case?
That students would do better on an open book test? Yes, maybe. So I strive to make my exams all high level so that having open book doesn't necessarily help you on the exam unless you've just forgotten some content. And so I actually am doing open book exams now in my classes consistently because having that content barrier, that's not as important to me as being able to apply the skills. And we see that students do marginally better in the open book treatment than the closed book treatment, but their attitudes are so much better in an open book treatment because they don't feel that stress or pressure of having to recall content. So I'm a big fan of open book exams as long as they're high level cognitive skills where having content isn't necessarily your benefit.
Fantastic. And then we've had a request for what are your suggestions on reviewing material before the test?
So I'll tell you the way I do it. I don't know if this is the best way, but you saw that list of learning outcomes that I had. In fact, let's see, if I go back to the learning outcomes that I was showing you examples of, tested and untested here. So you can see the learning outcomes that I have. I give them learning outcomes from every day of what they need to be able to do. So notice this is not a list of content they need to know. It's a list of skills they need to be able to perform. And so what we actually do is we do one day, one class period prior to exams. I make it a free optional day, and all the TAs are there and I am there. And I put up these on the slideshow, I put them up, and then I have students all talk to each other, and then we just walk around and facilitate discussions with groups. And I tell them to do the following, like look at the learning outcomes. So if it says predict which assumption's been violated given allelic frequencies of two populations. This is day 17, number 2. I'll ask them, okay, what did we do in class where we did that? Or what did we do in a homework assignment where we did that? And then can you come up with an exam question? What would an exam question look like? And usually they can say to me, gosh, you'll probably give me allelic frequencies of two populations and ask me which assumption's been violated. And that's exactly right, right? So as long as your learning outcomes are aligned with your exams, which they should be, right? If they're aligned, then giving them the exam should never be a surprise for students. They should be able to predict exactly what the exam looks like. So we just spend an hour letting the students go through these and practice.
Great. And let's see. Give you guys another 30 seconds in case anybody else still has questions they would like to ask. All right, so we've had, were the students given timed exams? Were the exams online? I might have missed this information.
Okay, yeah, so in the actual experimental setups, they were taking them in our university testing center with no time limit. Now, when I do the open book exams, I do put a time limit on it because I want them to prepare for the exams and not just count on being able to look everything up. So if I have, 30-ish questions, I'll give them about 2 hours to complete it so that they don't look everything up. So it depends on whether you're doing open book or closed book, I guess.
Great. Awesome. And it looks like we're wrapping up on questions. That was the last one. So I will start to wrap us up because it's about 10 minutes until the next session now. So, thank you everyone again for spending part of your morning with us. And thank you especially to Dr. Jensen for your really wonderful presentation. I think it's been really knowledgeable for me as an outsider to the classroom. So I can't imagine how useful it's been for everybody in our audience. And as a reminder to our audience members, we do have 7 sessions today in the virtual summit. So if you haven't signed up for the rest, you can still do so on our website at CourseKey.com. For those of you who have signed up, those start at the top of every hour through 3 p.m. Pacific time. So hope to see you at more of those. And also online, if you like these events, you can sign up for more by subscribing to our mailing list. That way you'll never miss a webinar or a future virtual summit. And just, thank you again. And we hope to see you again later on today. And thank you again to Dr. Jensen.
Thank you.